Hi everyone, my name is Severino Jefferson. I'm a PhD student at Fiocruz, Pernambuco, and today I'm going to talk about the work I had done my PhD with the title Developing a lab box in low-cost paper-based sensors for Zika and chikungunya diagnosis in Latin America. So the Zika virus represents a great concern for political health in several countries, ultimately because the Zika virus infection was commonly associated with the development of neurological disorder in newborns. So regarding the diagnosis, the Zika virus infection can be diagnosed using some approaches, include clinical diagnosis, serological methods, and molecular techniques, where actually RT-qPCR is the gold standard method for the diagnosis of Zika virus infection. However, RT-qPCR has several limitations, such as high costs, which limits the application in lower resource countries and scenarios. In this context, the development of point-of-care tools are critical to face the healthcare problems. In example, we have the sensors. So in this context, the aim of this work was to develop low-cost, paper-based sensors for Zika and chikungunya detection and lab-in-a-box hardware to assist the visualization of results. So initially, we developed the sensors for Zika and chikungunya detection using computational tools. And then, in order to assist the visualization of results, we evaluated a lab-in-a-box optical reader. Basically, the optical reader maintains the temperature at room temperature, the 37 degrees, and after the end of incubation, automatically generate one report with the results. So, in general, this workflow represents our methodology for testing the patient samples, where initially we collect the samples from patients, including serum, urine, saliva, and semen. Then we put the samples in our bath during 2 minutes at 95 degrees Celsius. And then we put the template into census reactions and subsequently incubate using our lab-in-a-box during 1 hour at 37 degrees. And after the end of incubation, the results can be easily observed by naked eye, and they also use our lab-in-a-box. So initially, we evaluated the analytical specificity or using our sensors for detection of Zika virus. And when you can see here, our test was very specific for detection only Zika virus against other arboviruses circulating in Latin America, including dengue virus, serotype 1 to 4, yellow fever virus, chikungunya virus, and malaria virus. And also, we confirmed these results with the RT-qPCR, the gold standard method. Then we evaluated the analytical sensitivity. For that, we did a serial dilution of Zika virus and then tested side by side using their sensors and RT-qPCR, and the results demonstrate that a similar sensitivity between both techniques. Finally, we validated the sensors for Zika virus detection using 268 patient samples from 3 different countries in Latin America, including Brazil, Colombia, and Ecuador, and the results demonstrate an accuracy of 98%. Then, we adapted the system for chikungunya diagnosis, where initially we evaluated the analytic specificity, and you can see here our test was very specific for chikungunya detection, and cross-reactions was not reported against other important arbovirus, including dengue, Zika, malaria, and the yellow fever virus. So in the also, we confirmed the results with the RT-qPCR. Then we evaluated the analytical sensitivity, and the results demonstrate that our sensors is 10 times lower when compared to the RT-qPCR. And finally, we validated the system using 65 patient samples from Brazil, Colombia, and Ecuador. We demonstrate an accuracy of 98%. After our experiments, we had the one question: how much does each test cost? Based on the price of our reagents, the price was $1 for sensors and for RT-qPCR, $11. Based on our results, we have a manuscript under review at Nature Biomedical Engineer. And more recently, we applied this same system for SARS-CoV-2 detection. And you can see here the results for sensitivity, specificity, and evaluated with some patient samples. In general, we developed a low-cost based sensors for Zika and chikungunya detection. And it's interesting, our system can be easily adapted for any pathogen. More recently, we deposited a patent and created a startup for produce and provide the sensors for healthcare application in low resource countries. Thank you.